Okay, so today we are going to discuss about symbolic mathematics, right? So far, we have discussed about normal computation, or generally, whenever we evaluate any expression, we require numeric value or some string, anything. We have to give some value. After that, you can evaluate any expression. Sometimes we want to perform any mathematical operation over the variable itself, whatever the symbol we have. For example, I want to take a differentiation of sine x, right? So I am not interested to give value for x. I want to get what is the differentiation for that sign. So in terms of x, I want to that differentiation. So that is possible in symbolic mathematics. In symbolic mathematics, you can provide symbol as a input. Okay. So it's another way for doing computation using symbols. So we are using symbols here. Therefore, we are calling it as symbolic computation or symbolic mathematics, right? So it is performed using symbolic math toolbox. If any error is coming to your system once you type sims, right? Whatever we use for defining or declaring symbols, if that is undefined in your system, that means there's no math toolbox, mathematics toolbox, symbolic math toolbox. So you have to install that symbolic math toolbox. Okay, so it comes under symbolic mathematics toolbox. So the data type is symbolic object. Okay, whatever will be calculated, whether it's a character, anything, everything you will find in symbolic object. Okay. Okay, so how we create these symbols? So we have two ways to create symbols. One is SYM, sim, and other is sims. By using sims, we can create any symbol, individual symbol. Uh, so if I simply write, I start diary before that, diary day 20. Simply I write sims. First I am typing x. Okay. When I write x, unrecognized function or variable. But if I write sims x, okay. Now if I type x, now x is x. Okay. Now x is x. If I do x plus 2, then I'm getting x plus 2. Now x is not undefined. Okay. So once you define something as a symbol, you can use that as a symbol. Okay. So by using sims and like this a, b, c, you can define any number of symbols. So now a, b, c, all these are available in symbols. So here you can check the data type for these is sim. Okay, class is symbol SYM. So whatever calculation you will perform, all will come in symbolic. Okay, if I write simply a multiplied with x, writing procedure is same. B, you cannot write like this BC. Okay, you have to write B multiplied with C like this. Suppose you are storing this in some Y. At this time, I have not defined Y as a symbol. Okay, I have not defined this Y as a symbol. All these things are defined as symbol. Obviously, after the computation, whatever the result will be there, that will in symbolic. So Y will automatically declare a symbol. Okay, so now I'm getting Y this, and Y is also symbol. Okay, so whatever computation you are doing in left hand side, automatically that will assign to the variable, whatever variable you put in the left side. Okay, yeah, in the right hand side, whatever you're writing. I hope it is clear. Okay, so this is one way for creating symbols. If you want to create individual symbols, okay, by using this you can also create symbol sims x, but for creating individual symbol, this is not a good way. Okay, obviously this is a function. This is mainly useful whenever you want to create some matrix, matrix of symbols, we can say. For example, you want to create a matrix for P, their size is 1 cross 5. Okay, you want to create a matrix that is 1 cross 5. that is a row vector basically, and P will automatically assign for each element. Okay, so in that case you can create that. So I simply write P is S by M. Okay, then P. After that you declare the size. Okay, now you can check. Now P is a row vector which have symbol P1, P2, P3, P4, P5. Okay, all cannot be P obviously. So 1, 2, 3, 4, 5, that is also attached. Okay, so now if you want to access any symbol, the procedure is same. Suppose if you want to extract this symbol and you want to store it somewhere, suppose you want to store it in Q, so you can simply use the same indexing P4. If I write P4, you can access this element. Okay, you can check. So whatever we have learned in the starting, all concepts are applicable here. Okay. Now I want to create one matrix. So suppose I want to create a matrix of this size. Any size you can create matrix. So now if I change this size, suppose, okay, then what happens? Now you can check. Now this is P11, 1 underscore 1. Okay, this is a by default representation. First row, first column, first row, second column, like this. Okay, so this is automatically created. I have used here P. If I will use some other variable here, it will generate according to that. Okay, I am getting according to Q. So whatever variable you want here, just write that, and these things will be automatically created or attached with that variable. Okay, because these all should be different. Huh? That's why. So this sims is mainly useful for creating these matrices, right?
Sir, what happened if sims I used SYMS?
If you
instead
use
of
sims,
sim?
no, you can use, but you have to actually create each variable. Then you have to assign that location also. You have to arrange all those variables. For example, we have already some variables. So suppose I want to put those variables in some R matrices. Okay, I want to create one matrix R. So you have to put those variables in that position also. Suppose I have A, B, then I put C, right? And after that, I have suppose X, like this. So now I have this matrix. So by using that sims, directly you are able to create one matrix. Okay, and that is also creating variables. If you use that sims, in that case you have to perform two operations. First operation, you have to declare each variable, right? Sims like P1, P2, like this. After that, you have to arrange all these symbols in matrix form. Got the idea?
Yes, sir. So simply we can use sim anywhere, SYM, to avoid this.
Yeah, that's sim. Yes, whenever you want to
abstraction.
create any matrix, then use that sim. And if you want to create single variable, then use the sims, right? So that's why I use these two things. But it can also create an individual X or any variable, but that is not a good approach. No? Sims is very simple in that case. So this is mainly useful for creating matrices. Okay. Now we have another function that is sim_var. As such, it does not have any use outside, but just to get understanding how the MATLAB decide the sequence or priority of the variables. For that purpose, this function is useful, right? For getting understanding of that thing. Suppose you are passing only one variable in some function, then by default, what symbols will be considered for the operation? Okay, so we will use all those things later, but this will define the sequence basically. Okay, for example, so if I write this sim_var, it returns the list of all symbols. How many symbols we have in any expression? Okay, suppose here we have one expression y. So we are using 4 symbols. So if I write sim var and I write y, then it is returning all the variables. Okay, these are the 4 variables that we are using. If I write y comma 2, okay, if I write this y comma 2, then what 2 variables or 2 symbols I will get? Okay, simply when I'm writing 2, that means I want to get the information about the 2 symbols. Okay, now we have 4 symbols. So what 2 symbols we will get? So we are getting these 2 symbols. So why we are getting these 2 symbols? Okay, why we are getting these 2 symbols? So for this, actually x is the reference point. We can say x is the reference point, small x. Okay, so whatever variable is nearby this x, that is always considered. Okay, that is always considered. Whatever variable we have near to this x, that is considered. So obviously out of these 3 variables, c is the nearest one. Okay, so that's why it consider this c. Obviously x is there, so it considered that x, right? Just a minute, just a minute. Yes, yes. Okay, so this x is the reference point. If we have that x, obviously that x will be considered, and whatever is nearby this x, that will also consider. Suppose I write here 3, so obviously it will include this b also. Okay, if you have some capital letters also, in that case the sequence is like this. This is x, then obviously this is y, this is z. Okay, so the nearest one to x is y, then next is z. Okay, then w, and so on, a. After that capital letters start, z, y, x. Okay, so the capital A, this one, is the farthest from this x. So if you have in your expression this capital A, that means it will have the least priority, right? Or at the end it will be accessed. So in this way we are actually get the access of these variables. So whenever you are performing any operation, and if you are not giving the name of variable, for example you are performing differentiation and you have not given the variable name, in that case this function will automatically get the idea about the variable, what variable has the highest priority. If x is not there, if x is there, by default it will perform differentiation with respect to x. If x is not there, in that case it will use this function, and according to that it will decide what variable is there, and it will perform differentiation with respect to that variable. If you are not defining the variable with which you want to perform the differentiation operation or integration operation or any operation. Okay, so for that purpose it is used.
Sir, can you explain this once again?
Actually we are going to use this. Okay, so I will again when we will take one example, hopefully it will clear. Okay, and yeah, or I can write one more expression, then it will be I think suppose
one expression without x.
Yeah, yeah, exactly. So I am defining more variables. Okay, w I am taking then w is there. Okay, z is there, then I'm taking a. So I define some more symbols, and simply I take one expression. Okay, a multiplied with b plus I'm not considering x, okay, or even I'm not considering y, z also, c plus we can take this a also. So now we have this expression, and if I write simver s comma 2, okay, if I write simply s comma 2, so now what two variables should I get, or two symbols? What two symbols are nearest to x? Because x is not there, but x is always reference. Okay, so you have to check what is the nearest to x. So obviously we have one w that is nearest, wx, okay, and after that is c is nearest. So we get these two, c and w, we are getting. Got the point? And if I say suppose if I say 4, okay, 4, then still I am not getting this a, because as I told you the sequence, a is the farthest, right? A will be accessed at the end. So here small is there, a, b, c, everything there, but we are getting this a at the end. It is written here. This is not the actually point. It is written in starting. You can write it anywhere. Okay, you can write it anywhere, but its priority is I can say at the end. Okay, first small letters, then after that capital letters. Clear or not clear?
So it will follow the alphabetical order. I mean, with respect to small x.
With respect to x, actually, what is the because we can use any alphabet randomly, na? In our expression, any alphabet may be there. So it will check what alphabet is nearest to x. Okay. Actually, this is whenever you are not deciding the variable. In that case, sometimes some expressions are written and differentiation or with respect to what variable you are performing operation, that is not written there. So just to get understanding of that, this function is useful, or internally how MATLAB decide that. Okay, actually we are going to use some example further, then you can get the idea about that. Obviously it is going to use throughout, so this is just starting. Okay, by the time it will clear. We have one more function, that is substitution. We can substitute something in place of some variable. If you want to substitute some value there, or you want to substitute some symbol itself, that is also possible. Okay, so here it is also useful. Whatever function we have used, this is useful here also. Suppose I have some expression. Okay, now you can understand. I have one expression, s is equal to this. Okay, if I write subs substitute, I want to substitute in s. Okay, and I am substituting this z. I write like this. So actually I am substituting this z in this expression s. But for what you are substituting, what you are substituting for this z, that is decided by that simware function, right? Good thing is that just declare I want to replace this c. I want to replace this c with this z. Okay, if I write in this way, because z is not a symbol, so I cannot use that z. So we can use some other symbol. Okay, I have a there. So or either we can.
It shows sir small z, sir.
Yes. Yeah, we can use the small z. Small z is there, na? So we can use that. So suppose I write a small z. So this c will be replaced by this z, right? So you can check here. This is now wz. Okay, so this c is substitute. So we are writing clearly. But if I write simply like this, okay, if I write like this, then what should be replaced? right? What should be replaced with this z? In this case, I have declared, yes, I am going to replace this c, but here I have not declared. So what variable will be selected for the substitution, that will be decided internally by that function simware, what we have learned. So obviously we know that out of all these variables, w is the nearest to x. X is the reference point. So this w should be replaced with this z. Okay, so you can check here what happened. Yes, so yeah, we got the correct answer, but this is not replaced. Anybody can tell me why we got this answer? Because I was expecting it should be z square, because we have z and one more z, so z square. But I got this cz. Why? Just look into the screen and got the idea. Where is the problem?
So because these are symbols.
These are the symbols. Actually, whenever we are executing this, whatever result we are getting, that is stored in ANS variable, right? By default, S is not changed. S is this one. So actually by using this, we are substituting something in S itself, not in ANS. Okay. So this expression was stored in this ANS. That's why it is not updated. So actually in S, we have this expression. Okay. So in this expression, when I executed this, so it checked, yes, this W is nearest. So it replaced this W with Z. So I got this expression. Okay. Got the point? Why we not get a Z square? Because this was not stored in S. Okay. If you want to update that variable itself, then you have to write this substitution and S is equal to. If you're writing in this way, suppose I repeat those instructions again. If I write in this way, now this S is updated. Okay, now S is updated. And again, if I write in this way, now I'm getting this Z square. Clear or not clear? So sometimes we also get confused when we are writing, how we are writing, what we are getting updated, right? Sometimes we expect something, but we are committing some mistake. So here, that was a mistake, but actually that was not updated in S. And I was thinking that it should be updated. And I got some different answer. So we should be able to get the idea. Where's the problem? What we are expecting that we are not getting. So here I am not given any variable for what I am substituting, but by default it is substitute for that. Again, if I substitute it, okay, now what is the next variable? Now it will replace, again I use this. Now actually Z is there and it is replacing that Z with Z. Obviously Z is the nearest, so no updation is there. Right now, no, obviously you are trying to replace with Z and Z is the nearest one, so it is replacing Z with Z, so no change. Okay, something is cleared or get more confused? So here I have written these two expressions. So this is the expression or variable, anything that you want to replace, and this is the symbols or any expression that you want to put in place of this A. And if you write simply this A, that means this is the value that you want to substitute. Okay, in that case it will automatically decide what should be the variable. Okay, so here are some examples. I written y is equal to 5 is equal to 25. Then evaluate y for A is equal to 2. Okay, so I want to substitute 2 in place of A. So in that case, I can simply substitute y. So I have stored this one in y, or either you can directly write all these things directly at this first position. Okay, you can write here. And after that, I decide what variable you want to put, actually, what substitution you require. So I want to put 2 in place of a. So a will be replaced by this. Okay, and you can check what will be the output. Okay, so suppose I write here sims a b c. I write y is equal to 5 a square plus 25, suppose. Okay, I have this expression, and I substitute y is equal to, if you want to update that variable itself, then you have to write this in left hand side. Substitute y comma a comma 2. Okay, so I am getting this 45. So this is a 4 5 is 20 plus 25 45. Okay, now this 45 is symbolic. Okay, this is symbolic. If you add something in this, suppose you add 100, okay, you are getting 145, but again this is symbolic. This answer is also symbolic. So everything is here in a symbolic format. Okay, that is symbolic. But we can substitute anything in place of that, and you can substitute some portion or some expression also. Suppose I have a plus a multiplied with b. I want to replace this a multiplied with b with 5. That is also possible. Okay, so if I write in this way, a plus a multiplied b, this is the expression, and I want to replace this a multiplied with b with 5. That is also possible. So you will get a plus 5 at the after the execution of this statement. Okay, so we can replace some portion or some expression also. It is not necessary you should have only one symbols there. Okay, so we can check this one also. So if I write y1 is equal to a plus a multiplied with b. Okay, and y1 is substitute y1, then a multiplied with b, and I want to replace this with 5. So you can check, I'm getting a plus 5. Okay, so you can replace any expression. That is also possible. Okay, if you want to put multiple actually substitution, you require multiple substitution, that is also possible. For that you have to use these curly braces, right? Cell arrays concept. So this is the expression in which you want to perform these substitution operation. These are the variables for the substitutions, and these are the values. Okay, so if you have more than one variable, in that case you have to use these curly braces, cell array concept, right? And you write one variable, second variable, and in the same sequence, this is the substitution corresponding to a, and this is corresponding to this b. Okay, and this is the expression. So let's see here, if I write this alpha, sim alpha, when I'm writing in this way, I'm able to create this alpha symbol also. Okay, this function also create these symbols. This is one additional use of this function. Okay, simply if I write in this way, so you can check CLC, I write y2 is sine a plus cosine b. So I'm getting this expression. Okay, now I substitute y2, okay, then a comma b, then sims alpha, then I write this value Okay. So you can check. So what is the problem with alpha? SYM. It is not alpha is not created. So the spelling is correct. ALPHA. ALPHA. Maybe yeah. If I do this in a live script, maybe the possibility in live script it will do that conversion. Okay. So if I use this, I copy this and I paste this here. Okay. Obviously, you have to write. At this time, it can use the workspace, but if you try to run this individual, in that case, it may create problem. So first of all, you have to use this y2 also. Y2, then sims A, B, right? Yes. Now, if I run this, yes, you can check here. I'm getting this alpha. Okay. So in a normal command window, we are not getting that. So actually, this is the function of MuPad, as I told you later previously. This is the function of MuPad. MuPad is also one tool for the MATLAB that is integrated with this live script. So whatever equations we are writing, any symbols that you can check here, is coming in a very nice way. Okay. So when I write here alpha, that alpha is created. That's why I was not getting that in command window. So whenever I generally discuss about the symbolic maths, I prefer this live editor, or especially whenever you are working with the symbolic maths, use this live editor. Okay. Or
Sir,
live M file. Yes.
Sir, how is this happening? I mean, B is replaced with 2 and A is replaced with alpha. I mean, can you explain the expression once again?
Actually, this is the expression sin A cos B, right?
Yes,
now we have used this function substitutes, right? So by using this function, we can make substitutions. So these are the variables for which we are looking for the substitutions. Okay. So first variable, for first variable, I want to substitute this alpha. Okay. So A is with sign. So we will get this sign alpha, right? With sign, obviously. And this 2 is corresponding to B. So B is with cos. So we are getting this
Sir,
cos
so
2
sir,
plus sin alpha.
sir. So if we put alpha in the sims like A, comma A, B, and alpha, and don't use the sim in substitution, so will
In
it
that
work?
case, it will use alpha as alpha. But here we use the sims, na?
Okay.
So
Okay.
it is converting that to this alpha
okay,
symbol.
okay.
This is also one use. I told you, na? This
Okay,
is
okay.
one additional use of this function.
Okay. Okay.
Okay. Yes. So now you can make any number of substitutions. So whenever you want to perform substitution for more than one variable, then you can use this concept, cell array concept. Clear?
Yes, sir.
Okay. Now we can move for calculus, how we can perform calculus operation using symbolic mathematics. Okay. So if you want to perform this differentiation, so for the differentiation, we have function diff, diff. Okay. And whatever expression that you want to perform differentiation. So if you simply write diff y, it will automatically choose the variable, okay, based on the simvar with respect to which it want to perform that differentiation operation. For example, if I just add here, or I can create one section, insert section break. Okay. differentiation sims, I'm not considering x. Okay, I will consider other variables. So I take y. Okay, and a b already is defined. C d e, we can take any variable. Okay, now we can write any expression. Suppose I write some expression, k is equal to a. Suppose I use this, or in place y, I can use any other symbols. Suppose a c square plus, I'm taking anything, right? So you can get the idea. Suppose this is the expression, for example. Okay, and I want to perform differentiation for this expression. So suppose I write k underscore diff. So I write diff and k. I simply write like this. Okay, I just increase the size of this so you can visualize properly. So if I run this section, I'm getting differentiation k diff is c. Okay, I'm getting k diff c. Now why I'm getting this c? With respect to what variable it perform differentiation? AC square plus DC, AC square plus DC, I perform differentiation k. So what variable it selected for the differentiation? Getting idea or not? I have not given here name of the variable with respect to which I want to perform differentiation operation. I have here a variable, c variable, d. Okay, I have 3 variables. So when I am not passing here any variable name, okay, it will use that simware function. And according to that, out of this a, c, and d, d is the nearest one to the x. Okay. If you go into the alphabets, obviously d is the nearest to the x. So it considered d as a differential variable, right? With respect to d, it performed the differentiation. So in this term, we get c, and these two terms considered as constant, ac square. And that becomes 0. So we are getting c. Okay. If you write here c as the variable, you want to perform differentiation with respect to c, so you can write the variable name itself. Okay, now there is no confusion. Now it will perform differentiation with respect to c. So if I run this, I'm getting different result. So it's a d plus 2ac. Okay, so whenever we are not giving this variable name, in that case, that simware function is useful. Hopefully now it is clear what is the use of that simware function. So that is basically for internal purpose, or whenever some variables are not defined, you should be able to understand what is exactly happening. Yes.
Yes, sir, clear.
Clear? Okay. So after this, we can give the order also. Okay. You want to perform second order differentiation, first order, third order. So by providing that value, suppose you write here c comma 2. So now it will perform second order differentiation. Okay, second order differentiation. So simply it is performing d dc square. With respect to c, we are performing second order differentiation. Okay, now you can check if I run this section, I'm getting the second order. Okay, so in first order, it is d constant. I hope it is clear. Now we are getting 2a. So any order of differentiation you can perform by using this. So we have the 3 input variables. One is v is the variable with respect to which you want to perform that differentiation, and n is the number of or order of the differentiation. Okay, So I hope you can perform this operation. So this is one example. So these are the variable name. So obviously you cannot write this in left hand side dy over dx. You cannot write. Obviously this division is not applicable in a variable name. Okay. Obviously all these are the variable names. So we have to use those valid variable names. So I use dy dx just for representation of this dy dx, and use diff y comma x because I want to perform with respect to x. So if you will not write this x, it will also perform the same operation. Okay, because x is the highest priority. But if you want to perform differentiation with respect to t, in that case you have to write this t. Okay, so dy dt is y comma t, and for second order we have to pass this number also. Okay, second order. So this is about differentiation. Now suppose I extend this discussion with some previous concepts also. Suppose I want to plot something. Okay, suppose I want to plot some expression and that differentiation also. So suppose I create one section break here, and suppose I write sims x y, okay, and I write some expression y is equal to e to the power minus 5 multiplied with x, okay, multiplied with the sign of x, like this. Okay, now I have this expression. Okay, in y1 I store differentiation of this diff y. Okay, now I have differentiation of this. Now I want to plot these two. So we have f plot function, right? So we can plot by using f plot. Then we can use these two. I can pass this y comma y1, and I can pass the limits. Suppose I want to plot this between 0 to 10. Okay, like this. So if I run this section, you can check it out. So we are getting this output. So we can do one thing. If I simply plot 1, you can check. So I'm getting this kind of output. Okay, sine. For that I'm getting that output. If I write here y1, you can check. So this is the differentiation. We are getting this output. Okay, and if you want to plot both, you simply write y comma y1. You are getting plot combinedly for both. So one is differentiation, other is normal. Okay, so that is also possible, but in this case we are not getting any array or all these things here. You are getting everything in a symbolic form. If I write here y1, so this is the expression basically. Y1, if you write, you have the expression. Okay, if I evaluate this y1 simply here, you can, okay, now when I'm evaluating, this is evaluating the command window. Okay, so I can just remove this, then you can check. So this is the expression. Okay, so you can check the difference. In command window we are getting this kind of expression, and in this live script we are getting this kind of expression, right? So this is some in a bookish language that is more understandable, right? So this is the differentiation, and for that we are getting these plots.
Sir, we can use plot function also rather than a plot.
Plot for this function plots, actually we are plotting the function. So I think plot is not valid. Let's check plot. I have not used plot. Let's check. No, data must be numeric. So plot is useful for the plotting
No,
numeric
sir.
kind of it.
We didn't give the range
Oh,
for plot wise.
no, actually you have to evaluate for that. Again, you have not given range. In this, we cannot give range in this way. Na? You have to evaluate that at some points. Here we have just declared this expression, again declare this, okay? And after that, how you will evaluate? Either you have to substitute values, after that you will get, and obviously it used for the numeric kind of data, but here we have symbols, right? Symbolic. So that's why we are using this. You have to use, actually you have to, you can do one thing.
If we can, sir, like previously,
I'm
we
giving
give
some range for that, but we cannot give range in this way. Let's see, possible. Suppose I take this. Let me check. 30 2 pi. Okay. Now suppose I declare in this way, and now I have x and y, right? Let's see. No. This one, yeah. So we got values for, yeah. Yes. So we provide all these values. After that, we are able to do that. Yes. Yes. And we are getting y1 also. So now if I use x comma y1, what is the problem with y1? Plot vector must be the same length. Oh, here length is different, huh? And when we perform differentiation, the length become different.
we can use, sir, hold on.
160. Yeah, in that case, you have to use two function, and obviously, whenever you have different number of points, in that case, hold on is the better option. Hold on, and after that, you can use plot x comma y1. But here again, x will have more number of points now. Yes, we can write simply this y1. Yeah. So we are getting. So hold on. So just to perform that, you can check. We have to perform or we have to take extra effort, na? I add this line, all these lines, and still I'm not getting that kind of plot. So that is that. But we can do, yes, that is verified. We can do that. Okay. Yes. For the integration, we have function int. Okay, int in the same way, just pass y and int and the variable with respect to which you want to perform integration. Okay, so if you want to perform the integration of these expressions, so we can perform this integration simply int y comma t and int w comma x. Okay, so this is the indefinite integral. If you want to perform definite integrals, integral with limits, function is same. You have to pass the limits. Okay. Here, first variable is the expression. Okay, for which you are performing integration. Second is with respect to which you want to perform integration. If you pass these two limits, okay, these two limits, then it becomes definite integral. Okay, so here you can pass the variable with respect to which you want to perform that integration and then limits. Okay, so a and b, so a is the lower limit, okay, and b is the upper limit. So like this. So if you want to perform or you want to evaluate these integrals, you can evaluate. So obviously these are written in this way in a book, but in MATLAB you have to use this int function, right? Once you write this int function, that means this integration is done, and after that this expression you will write, and after that if there is x, no need to decide or write that variable, right? This is your choice. If you want to write, you can write, and after that you have to put these limits x comma, this is the a limit and this is the b limit 1, and you will get the result of integration. Clear na?
Sir, can we perform double integration also?
Double no as we can do in the differentiation, we can pass the order of integration here, sorry, order of differentiation. Here we cannot pass that order. Okay, you have to perform separately. Double
Okay.
integration we cannot do in this way. I have not did that actually. You can further explore, and I have not seen also. Okay, because day by day things are getting changed, new functionality are getting added. So if something is new added, I'm not aware about that, but so far I think only single integration is possible, okay, in this particular function int. Okay, so I think you can perform these integration, or should I demonstrate one? Simple code.
Yes, sir, we can do.
Okay. Now, if you want to perform this limit operation, you want to take limit, that is also possible. For that, we have function limit. Okay, just use the limit, and this is the expression. So when you write simple expression, you are not passing any other variable. In that case, it consider by default x tends to 0, right? X tends to 0. So if you want to change this to something else, then you have to write that. Okay, so x tends to a. If you write here a, then x tends to a. You can change the variable also itself, right? So if you have this kind of expression, then simply you have to write this sin x over x in f. Okay, you enter the f, and after that you can substitute. Okay, if you simply write this in limit f, obviously here we have x tends to 0, so no need to write additional things. You simply write limit f, then this will be evaluated. Okay, so we can check this. Here I can check. So I write limit. Directly you can write expression also here, sin x over x. Okay, so this is f basically. So something is wrong. Limit sin x over x. What is the problem? X is defined as symbols or not? X. Oh, x is something else, na? So we have to clear the workspace and sims x. Okay, after that I can perform this operation. So I'm getting 1. Okay, so this is about the limit. Limit can be done. After that, if you want to perform factor of a polynomial, okay, you have some polynomial. If you want to perform factor of this polynomial, that is also possible. So if I enter this, you can get the factor of this polynomial. Okay, so you have to enter polynomial in the same way. You will get factored form in this way. Okay, and again, if you want to expand, you want to get back this form. Okay, you can use this expand function. Expand, but we cannot get this directly. Okay, we cannot get this directly. Let's see what is the actually problem, why we cannot get back this directly by using expand. So I write this here. So I add one more section here. Okay. So I clear all y, or yeah, sims. I have to initialize sims x y is equal to, let's see what is the x cube plus 6x square, x cube plus 6x square plus 11x plus 6. Yeah. So after that, I perform the factor. Suppose I stored in f factor of y. Okay. So if I run this, I'm just making this in line, so it will be easy to observe the output run section. Okay. So I'm getting these factors: x plus 3, x plus 2, x plus 1. Okay. If I write here again factor, and after that expand f. Okay. If I write expand f and run section, I'm getting same thing. No expansion is there. Okay. So actually, what is the problem? Here we are getting these three values, but these three values are like a row vector. Here you can check the size of f. It's a 1 cross 3. So 1 row, 3 symbols. Okay. So these are the three different symbols: 1 symbol, 2 symbols, 3 symbols. Okay. If you want to perform that expansion, these three should be in multiplication format. Then you can perform this expansion. Okay. That's why it is not expanding. So before that, what you have to do, you have to multiply all these three. Okay. You have to multiply all these three, or you can simply write here f1 f1. So when I write f1, that means I am talking about this x plus 3. Okay. You can multiply with f2, sorry, f2, then multiplied with f3. Okay. So if I evaluate this one, you can check here. This is the multiplication form, right? Now if I evaluate this, now I will get the same form: x cube plus 6x square plus 11x plus 6. Okay. So whenever you have something in the multiplication format, in that case you can get the polynomial from that. Okay. So it is performing reverse operation, but that result is in some different format. So we have to do that. Clear? So this is one nested or Horner form that is also possible. Okay. So if you do Horner here, Horner y, Horner y. Okay. You can check. So it will create one nested format of that expression. So I think here I have written this x the wrong way. It should be not like this. Okay, because there will be 1 power of x in the nested form like this. So this Horner form is also there. Okay, so there are some additional functions that are used in this. Now one more useful function is solve. If you want to evaluate some expression, you want to solve some expression with respect to some variable, that is also possible by using this solve function. Okay, so I take this simple equation ax square plus bx plus c. We all know the solution of this, so I use this one. So I simply write suppose y is equal to a x square ax square plus bx plus c. Okay, Let me define symbols. I don't know whether these are defined symbols A, B, C. Okay. So if I run this, so I'm getting this equation. Now I want to solve this. So if I write solve y, okay, if I write solve y, so obviously because there is x, so it will solve this with respect to x. Okay, we are getting the solution of x when I write in this way. We know simware function, how internally things are happening. So if I run this, you can get the solution. Okay, so these are the two solutions for this equation. So for x, we have these solutions. If you want to get the solution with respect to a, b, c, any variable, we have 4 variables here. You can get solution with respect to any variable. Suppose you want to get the solution with respect to a. So obviously for a, the rest thing will go another side and divided by x square, like that. So for that, you have to write here y comma a, right? Comma a, sorry, a, and you can get the solution. So I'm getting this. Okay, so this is equal to 0. So minus bx plus c upon x square. So for what you are getting solution, you can get that. Okay, so by default it is considering x. So if you not write this a, it given solution with respect to x. And if you are interested in some other variable, you can do that also, right? So this is the solve function. By using this function, we can solve equations also. Okay, you have a set of equations, you can solve those equations also by this solve function. So here we have 3 equations. Okay, so for writing this equation, you have to take this 5 in this left hand side. Okay, so you have to write this like minus 5 is equal to 0 in this format. You have to enter this equation in this format. Similarly, minus 10 is equal to 0, and this is plus 1 is equal to 0, like this. So you have to enter these equations. Okay, you have to enter these equations. After that, you can get the solution. So, and if you want to solve this equation, x square is equal to 9 is different equation, a single equation, and this is other question. So if you want to solve this x square is equal to 9, you can solve that also. If you write simply solve x square minus 9. Okay, so x square is equal to 9. That means x square minus 9 is equal to 0. So you want to perform solution for this. So if I run this, you can check here. I'm getting 2 solutions, minus 3 or 3. Okay, so this is one single equation. I'm getting solution for that. So if you want to solve 3 equations, we can solve that. Yes.
We don't put 0 here. I mean, just left hand side part.
Yes, yes, only yeah, left hand side part. Okay, so you have to arrange equation that way. So everything should be in left hand side and right hand side 0, like that, right? Yes. So I have written these equations. Okay, so I have written this in this way. I written y1 is equal to x square minus 9, then solve in this way. Similarly, I have written the second example. So I written first equation in y1. Okay, second equation y2, y3. Because writing all these equations in a single expression become lengthy. So I stored these things in these variables y1, y2, y3, and I pass these y1, y2, y3 in a solve function. That is also possible, right? So if I evaluate this expression, let's see what is the solution. So then I can take here one section break. Okay, this one. So when I run this section, so this is y1 equation. Okay, this is y2, y3, and as solve, when I use this, I'm getting answer in a structure. Okay, I'm getting answer in a structure. So if you want to extract that, you can easily extract. S is a struct which has 3 fields x, y, z. Okay, so if you want to extract value of x, you simply write s dot x. Okay, even if you want to add all these things, that is also possible. You can do like this: s dot x, s dot y, okay, plus s dot z. So when you are writing in this way, that means you are accessing this value. Now here we have this value, so obviously we can perform that operation. So if I execute this, you can get this, right? If you want to get an individual, you simply you can write in this way: x is equal to s dot x, sorry, s dot x, y is equal to s dot y, in this way, and z is equal to s dot z. In this way, you can write and simply put here the semicolon. So now you will get x, y, z value. You can check here. So x is this, y is this, and z is this. Okay. By using this, I am just extracting data out of struct. Okay. And we can perform directly any operation on the extract by extracting values. So don't get confused when I am writing in this way, or in some programs you may get this this way also. And especially in the optimization problems, whenever we have to pass so many parameters or so many values, we just consider one structure, and by using this dot notation, we can pass so many things. Okay, so you will come across about this structure format in many places. So it's very common use of this structure. So whenever something is about some variable, then dot, just understand, yes, it's a structure format. Okay, and I have discussed about the structure, how we can access data from the structure and how the data is stored in the structure, all those things. Yes. So solve function is clear. How you can solve the equations.
Yes, sir.
Okay. After that, if you want to perform this Laplace transform, that is also possible. So for the Laplace, we have function Laplace. You have to write simply Laplace and this ft. Obviously, this ft should be defined using symbols. Okay. For example, if you want to perform Laplace of e to the power minus 4t, yes, we know e to the power minus x, like that. So e to the power minus 4t, if you want to perform Laplace, obviously you have to define this t as a symbol, and after that you have to write this and use this expression. Okay, so we can check that. So I can do that on the command window also. So sims t, I write sims t. Okay, and after that I simply pass Laplace, and I can write expression inside this also. So exp minus 4 into t. So I'm getting 1 upon s plus 4. Okay, you can evaluate this, but yeah, 1 upon s plus 4 is simple expression, no problem. So obviously I use this live script whenever you have some complex equations or big equations, large equations. In that case, some substitution is also done automatically, some assumption. Yes, this expression is equivalent to this. Sometimes we write now where this expression is equivalent to this. This is whenever we have large equations, automatically that substitute. So obviously whenever you use this live script for solving equations, all those things, then you will obviously get the idea. Okay, so this is totally different part. We can say in the starting we are just evaluating the expression by providing some value, but here we are not providing any value. Okay, we are just multiplying the things. We are just evaluating based on the symbols itself. So obviously it is not solving. So very long expressions we get many times. Okay, so you can perform the inverse Laplace also. Whatever you got in variable, just pass that variable inside I Laplace. So I Laplace is the function for performing inverse Laplace transform. Okay. So in this way, you can perform the Laplace transform also. For the jet transform, function is jet trans. Okay. So same way you can pass the jet trans, then you can perform inverse jet trans also. That will perform inverse jet transform. For the Fourier transform, is also function. There is Fourier transform, F transform, like that. Fourier, I think. For you, that is Fourier transform, symbolic method Fourier. So Fourier is the expression, right? So Fourier transform, we have the Fourier of F. So you can get the Fourier transform, right? So further, if you require, you can explore these functions. So we should have little idea about the function. Okay, then we can do that. So I think this is all about symbolic mathematics that I want to cover. Okay. Yes. Any query?
Sir, we can compute gamma function also.
Gamma function.
Yes, sir. Yes, sir.
You can, yes, so many options are there. Obviously, all functions are working. Whatever value we are providing, whether we are providing that numeric or we are providing that is symbolic, I think it will work. You can try that. In all functions, it is working, right?
Okay.
Yeah, so many mathematicians use all these functions actually. Okay, so that is also possible. All plotting is also, we can perform that plotting also by using symbolic mathematics, right? Later on, you can explore this. Obviously, whenever you will require all these things, then you can explore. So the basic idea was just to get a little start. Yes, these are also options available. We can explore these options, right? And otherwise, we will only think, yes, whenever we want to evaluate something in the MATLAB, value is required. Without giving any value, we cannot evaluate any expression. So that was the impression before this lecture. Now you can say, yes, if we have the symbol, we can perform any operation over that symbol also. So that is the objective. Yes.
Yes, sir.
Clear? So, okay, so in the next lecture, we will discuss about the numerical computation methods that are very useful for solving problems, especially nonlinear problems and differential equation problems, all those things. And what is the use of the numerical methods, all those things. So I will start that in next class, Tuesday, right? Okay, thank you and good night.
Thank you, sir. Good night.
Thank you, sir. Good night, sir.
Okay, good night.